Okay guys, so this is a guide video. So you just want to follow along until you feel like you can go with it, go from there yourself. So you want to do as much of this on your own as possible. So consider this differential equation. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Okay, so I'm going to do that right now. I guess I'll put the zero slopes in first. So at -1, or no, I'll just go one at a time. All right, so at -1, 0, the slope is -2, so I'm going to use little dots to represent the rise over run, like very small ones, down to right 1. There we go. All right, now this one is -1, so I'm going to go down 1, right 1. Yeah, and if you do that method, the relative steepness is going to look good. At -1, 2, the slope is 0, and at -1, 3, it's up 1, right 1. Okay, now for an x-coordinate of 0, all of the slopes are 0. And then -2, down 2, right 1, -1, down 1, right 1, 0, 1, up 1, right 1. Okay. Now for part B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. So at this point, guys, it would be a good idea to pause the video and take a look at what we did in the lesson video, because this is just the opposite case. So instead of wanting dy dx to be greater than 0, I want it to be less than 0. So for part B, I'm going to say to myself, x to the 4th, y minus 2 less than 0. This is going to happen if these two factors, x to the 4th and y minus 2, if they have opposite signs. So if x to the 4th is greater than 0 and y minus 2 is less than 0, or x to the 4th is less than 0 and y minus 2 is greater than 0. So that would give them opposite signs. But guys, this happens never. So we need x to the 4th greater than 0 and y minus 2 less than 0. This is going to happen always for x not equal to 0, because it's an even exponent. And then this is going to happen for y is less than 2. So when we do our description of the points, we say all xy, and then we describe where x is not equal to 0 and y is less than 2. Okay, so that is the answer for that one. Now for part C, find the particular solution to the given differential equation with this initial condition, f of 0 equals 0. So I've got to, take this and cross multiply, separate the variables, and do the antiderivative. So this is part C. So I'm just going to do it kind of fast. I end up with 1 over y minus 2 dy equals x to the 4th dx. All right, so I've separated the variables. Y is over here, x is over there, and then we'll do the antiderivative. All right, and then here's a little aside. So f is y minus 2, f prime is 1. Yeah, so this does end up being f prime over f. So, yeah, so the antiderivative of that side is this. Antiderivative of that side is that. Now we got to find c. Use f of 0 equals 0 to find c. So I'm just plugging 0 in. So this is the natural log of the absolute value of -2 equals c. Guys, the absolute value of -2 is just 2, so c is the natural log of 2. I don't need the absolute values once I've like evaluated it. So absolute value of -2 is just regular 2. All right, now I put c back in. So we have natural log, absolute value of that, 1/5 x to the 5th plus natural log of 2. Then I'm going to put a base of e on both sides, so those will cancel. And then we get y minus 2 absolute value is e to the 1/5 x to the 5th plus natural log of 2. Then if I want to drop the absolute values, I just need to consider the plus and the minus case. Okay. And then I'll do a little aside. All right, so I want f of 0 equals 0. That's what I want. All right, so let me try the positive case. So the positive case, I will put 0 in for y, so I get -2 equals e to the natural log of 2. So -2 equals 2. That doesn't work. Okay, so the positive case does not work. Now let me do the negative case. So -2 equals -e to the natural log of 2. -2 equals -2. That one works. All right, so the aside is telling me that it's the negative one. So y minus 2 is -e to the 1/5 x to the 5th plus natural log of 2. -e to the 1/5 x to the 5th natural log of 2 plus 2. Okay, guys, there's that.